conversation.
There's a lot.
Mm-hmm.
500 earlier was going to be.
Okay, wait a minute, this supposed to be with your shoulder. But now it's silent. Remember, number 3.
Yeah,
it is
by
silent.
yourself. This group parent is probably by
You
yourself.
only just better whispering. That's that early challenge you were trying to build here.
I'm sorry, I was over here following directions, what?
That's enough.
No.
Question.
Yeah.
So in class, like, Monday going, these.
Okay, so we want to look at patterns of behavior right now. Because that's important for us to teach students, because that's what scientists do. They look for patterns in nature. Sometimes it's, if it's human, it's going to be a different science. It'll be social science primarily. But anyway, we look for patterns in the data. Not all data is going to fit into patterns. You're going to have some outliers, some anomalies. You should expect that, and your students should expect that for a number of reasons. Humans are trying to impose an organization on nature that is sometimes there, but sometimes it's not there. And so, we need to make sure we're not artificially doing that. And to make sure they understand that there are anomalies or things that do not fit in the data set. But you're looking for the general pattern. So, here's some things that people have reported initially. That they would make a set of observations and then they'd stop and think. And then they'd make the next set of observations. The first observations tended to be visual and obvious, and the second set tended to be more in touch. And you all made some measurements in there, so that may have been, it looked to me like when I was watching you, that tended to be latter part rather than the initial part. And they also said it was helpful to have instruction on this. And to have the list to reference. So I don't know how many of you went back to this list that I put up there. But here's what I thought about in terms of sharing teaching ideas. That when I put that slide, because this is this slide, and then the next slide was this one. I should put some kind of sound to alert you to it up there. So and the next time I teach this, there's going to be a sound on this slide to alert people that that's up there if they want to look at it. and people have reported that it was helpful to kind of use this as a checklist. So again, think about what you want your students to use. Is this a list they need to memorize? No, but if they use it enough, they are gonna have it memorized, but to still have that up there for them. They also said that new observations were based on previous ones, so they may have said something is a certain color, like it's beige, but they say, no, it's more of a gray beige or a yellow beige or something like that, so they tend to refine their observations. If it's familiar, they neglect to make observations on obvious characteristics. I've done this with a variety of objects. I've seen this done very well with children with using popcorn. Because when they come into the room and they smell the popcorn, they're going to make some observations, and usually a teacher can start listing those observations as the kids start coming into the classroom about the smells or whatever. And they'll also make some inferences with it. So I have done this with objects that are not familiar. So this is the one I usually use with my students, as y'all know, those of you who are my students. Because it's not familiar to them. You can't teach adults and kids the same way. I cannot use the same materials, which is really interesting to find out. So with adults, I do have to use something that's not familiar. With you today, we use some objects that you're going to be using later on today, and so I changed it so where we are using something that is somewhat familiar to you, but it's an object, a natural object that we're going to be using later on. And my students, they're thinking about their grade. How's this going to be graded, or what kind of grade am I going to get on this, etc. And then some of them said they thought about, is this an inference or a testable hypothesis? If they're thinking that far, am I making an observation or am I making an inference? So until you've taught the difference between observation and inference, then you will have less students who understand the difference between them. So these are some kind of reports that we've got about individual behaviors. And then with partner behaviors, what they've said is when they got with their partner, they've made many similar observations, which you probably found out too. Some were different. Some people made more observations, and some people made more detailed observations. Now, right here where it says made more observations, I deliberately watched you and tried to see kind of pacing where you are. I deliberately did not stop you before at least several people had stopped, looked around at their colleagues and said, oh, they're writing more, I probably need to. And so I saw several of you doing that, and I deliberately waited until at least several of you had gotten to that point. And I think you should do that with your students, probably more than several, probably a lot of them, to urge them to, it's a kind of a competition, if you would, that they're competing with their fellow classmates is, oh, they're writing more, I probably should too. Then people with more background tend to make observations, perhaps they were previously cued. I find that people with art training tend to make very good observations. And that might be something that you might think about working with your art teacher at the beginning of the year, and maybe supplying the art teacher with some natural materials. I used to share I got a lot of stuff to teach with. And so I would share a lot of my materials with the art teacher. I'd bring the art teacher into the classroom, and I would show them, all the stuff that I have, and I said, you're welcome to borrow any of this that you like. Very few of them were so fragile, or, that if a kid broke it, it wasn't gonna be the end of the world. There were a couple that I was more careful with. So you might think about involving your art teacher in with that. And then the people reported that there's cooperation, but there's also a kind of a competition. Can I do better? So again, that working with partners with your students can do the same thing. It can urge them to do better work or more work, if you would. And they also found out if they disagreed about what color beige it was, yellow beige or gray beige or whatever, that they would come to a compromise in it. And we know that this is one of the things that the business world is telling us, that they highly value people who know how to work together as a team, who can compromise and who can, have good discussions, not disagree. We're not saying to not disagree, but to have good discussions so that it ends up a better product, if you would. And they are complaining to us as public schools that we're not teaching that very well. I know Lori and I have had conversations, and we'll have some more today, about how she's doing that with her math classes, and teaching that kind of teamwork. Well, we have patterns in nature that are there because they're efficient or because they're not harmful. We cannot always explain why patterns are there in the natural world, and if you've been a student in my class, I've told you stop trying to explain why. You don't know why. For the most part, science does not know why in a lot of instances. We see patterns, we see correlations, but we don't know why they occur. But what I'm suggesting to you when you're talking about patterns in the natural world, they're there because it works. It's efficient. It would not stay in nature if it's inefficient. It would be by natural selection. It's going to disappear if it's not, doesn't keep the species going. Or they're not harmful. So oftentimes we see patterns. We don't know what they do. We can't see how they're efficient, but they're still there. So they apparently are not harmful, to the species. Okay, so the application of this skill everywhere. I mean, it's not only in science, it's everyday life to make observations. If I take my vehicle to the mechanic, I need to tell him it goes clunk clunk at 20 and zing zing at 60. I've got to be able to make careful observations. When I go to the doctor, I have to make sure that I give my observations in a chronological order, rather than, here and there and yonder. And so being able to make good observations plays out personally in a lot of ways as well as collectively, like in your schools. We had conversations last week about star review, how to make those better. And so the idea of the observations that you make into your classroom, that you bring into your school environment to improve that is very important. Well, one of the things that we see with the new standards is that skills have now evolved into a term called practices. And you see that, I gave you the handout there. We're going to start talking a little bit about, it's on the back page, it's the last one there. So what you can see is this, the third to the last slide is this one right here. So this framework for K-12 science education began it in 2011, and I'm looking for it. Do we have those?
Yes, it's underneath
All right, so all of you in science should have this book. If you do not, we have 3 more, and we can order more. And I personally like a print copy because I make notes on it, and I like the PDF, the online version. So I keep both of those and use them. So we have these today, as well as the NGSS that we'll talk about a little bit later on. So in the K-12 framework, or the framework for K-12 education, it redefines skills, which seems to be kind of isolated historically, to say, no, these are part of scientific practices, and they are more integrated. And so the reason they said that they changed to scientific practices rather than processes was that it was engaging in scientific inquiry requires the coordination of both knowledge and skill. So the practices being the skill as in processes that we tend to separate, and we don't integrate them like they should be. Also in the K-12 framework, we have what we call 3-dimensional focus. So you have, where are their packets? Alexis, these packets here. So we have a set of packets for you to keep colored copies out of the pages, because we want you, here. Okay.
class stuff that's up there.
All right, these are all yours to keep. Your tax monies at work. All right, so down at the bottom of the slide, whoa, come back. All right, so down at the bottom of the slide, it says see second grade handout. So in your packet, let me review a little bit. The first part of the packet your framework is divided into two sections. One is by topic arrangements, and that's the one we're gonna look at now. We'll come back to the other one later. So your table of contents is the first page, and it's by topic arrangements. So if you look at second grade, which is about right here on the handout, where my thumb is, second grade, and if you look, you'll see that it starts on page 13. And then if you look, let me see that, I need that packet, I don't have second page in mine. All right, so if you look at the next page, you'll see DCI, table of contents. And all of them are by grade level, if you would, or grade span. And so if you look at your DCI arrangements and look at second grade, about where this thumbnail is, and you'll see 2-PS1. Everybody see that? 2-PS1. So that's what we're gonna be looking at. We're gonna look at a strand of concepts in your standards. In this case, we're gonna be looking at the particle nature of matter, which is missing from our TEKS, but very fundamental in physics. So I want to show you what your standards say about that. So your next handout should look like this. So there's a storyline on the front that gives you some information, and then on the back, this is from the NGSS, not from the framework. So if you look on this second page, it says 2-PS1, matter and interactions. And all we're gonna look at is strand 1. So right here at the top, it says 2-PS-1-1. Everybody see that, second grade? And so what the next generation science standards are, tells us that by the end of the second grade, if students understand this particle matter of nature, they should be able to plan and conduct an investigation to describe and classify different kinds of materials by their observable properties. This is what students should be able to do. So this would be like a, unit test item or final grade level, end of the year. That's the only strand for matter and its interactions in K4. It's right there at second grade. So it would appear to me that in K4, all of the grades, that we should be looking at our TEKS and our lessons, make sure they have this understanding. The next page is grade 5, which has a 5 up there. You see that? And again, we're looking at PS1, strand 1, that's matter and its interaction. So the 5 on there means it's grade 5. I'm sorry, I didn't point that out before. PS, of course, is physical science, and this is strand 1, and then a substrand 1, which is the matter and interaction. So what this is saying for the particle nature of matter, for students to demonstrate their understanding of it, they should be able to do this. They should be able to develop a model to describe that matter is made up of particles too small to be seen. Many people think matter is like syrup, it's continuous, and that's not true. It's made up of particles like atoms or elements or molecules, etc. Okay? And so that's not well developed, particularly in K5. They start getting it in 6, but it's kind of all of a sudden, and it's not done well. So what they're suggesting to you here is there's a clarification statement in red, right after it. And it says, clarification statements say this is what it is. It says it is examples of evidence could include adding air to expand a basketball, compressing air in a syringe, dissolving sugar in water, and in evaporating salt water. And then it has, again, in parentheses, assessment boundaries. So this says this is what it's not. We do not mean this. It does not include atomic scale mechanism, so you're not looking at electrons, protons, etc. Okay, You're not even looking at atoms, really. Of evaporation and condensation are defining unseen particles, which an atom would be an unseen particle. So would a molecule be an unseen particle? Yes.
Just clarification for teachers higher at the grade levels. So in fifth grade, when we do talk about things, condensation, evaporation, because it's still there in fifth grade, is it okay for us to just refer to these as particles?
Yes.
Just say particles and
Yeah.
leave it at that?
Yep.
That doesn't,
Just general particles.
okay.
Just general
Just
particles. And then particles could, at middle school, include atoms, elements,
Right, but stick with
compounds,
just particles.
just particles. Yeah, none of the other language. No atoms, no elements, no
Right, because
molecules.
when we talk about dissolving that, so I say, well, they dissolve, it's still there, cause you can still taste the sugar, but it just breaks down into particles that you can't see.
Yes.
And just,
Yeah.
I don't go any further
Yeah.
than that.
And you have the indirect evidence with the air into, they gave you with the example here, you know,
Right.
blowing up a basketball or whatever, or a balloon. And you can't see air, but you have indirect evidence of it. And indirect evidence is an important concept in science that we do not, again, do well in teaching. It is still in, I forgot what grade level teaks, although the Streamlining Committee, and it was elementary, tried, yeah, they tried
Third
to,
grade.
they tried to delete it. And actually, one of the board members said, in reading, you know, we teach inferences, and in fact, I heard just the last 2 days, I can't remember where I heard it was, but there was a reading teacher talking about how difficult it was to teach inferences in reading. And I'm thinking, well, it shouldn't be difficult to teach it in science. So is there some way science in K-5 can help reading by focusing on inferences? Because babies make inferences when you play hide and seek with them, or you hide something from them, and they go back to where they thought you put it, you know, they made the inference that you left it there because that was the last time they saw you with it. So it's a natural thing that humans can do, but somehow it's, children are having difficulty with inferences and reading.
It's not just that K through 5.
In
Yeah.
K-5, oh,
It's
not,
also
yeah, not
middle
K-5,
school.
Middle school, yeah.
in ELA.
Uh-huh.
Yeah, okay, so how can, I mean, it seemed to me like that's an easy fix in science.
Well, the word indirect is only in one teak.
Pardon?
The word indirect is only in one teak.
Right, but, I mean, don't we know that in science? I mean, that's the importance of having a science background or the math background, that it may not be there because teaks are not perfect.
I did notice that our ELA students were memorizing a poem, a section of poem, and they were just working on the memorization, but they couldn't describe to me what each stanza was about, and like they weren't able to make the inference from the language about what the writer was truly trying to tell them.
I don't know, I think it gets kind of weird in language arts and arts, because you could have 3 people read the same poem and.
That's
have
exactly
3
what I was
completely
gonna say,
different
that
inferences.
you
I think
could
that may
make-
be where the difficulty
Uh-huh.
is.
Right.
And whenever you have a question on a standardized test, on something that's not standardized across different people. I mean, science, I think, would be easier when inferences was still in 5th grade.
Right, but if we're thinking about best practices, is science a concrete experience that might be helpful to them?
Right, right.
Because I agree, I think making inferences in literature is certainly going to vary, you know, depending on our background, our experiences, etc.
You would say, well, I'm gonna infer that it rained last night, didn't see it rain, but my car's wet, driveway's wet.
Exactly. But the teacher's not gonna say that. The students are going to be saying that. So one of the weaknesses that we see in everybody's classroom, including our mixed teachers, is there's not enough student questioning. There's too much teacher talk, like I'm doing right now. I take them to see Candace, my students in my course, to see Candace this semester. Also took them to see Laura. And one of the things that they observe, because they're out in blocks, you know, and different teachers, and one of the things that they reported was how much questioning Candace does with her students. Now, could she do more? Probably, as we all could. but, you know, we're not seeing that. So think about how we are gonna question students rather than telling them the driveway's wet or the car's wet. You know, what kind of inference can you make about what happened last night if you look outside? And maybe take them outside in the school, in the schoolyard to do that. Okay, the next thing I wanna show you is how this moves through high school. So you have one that says HSPS1. And notice up at the top, I didn't focus on this, but it says right underneath that top grade line, students who demonstrate understanding can. That's like the SEs. That's like the SEs. So again, this moves into high school in PS1, and it has all of these different strands, if you would, for PS1, whereas if you look at middle school, there was only one there. And if you look at the high school, you see a whole page of PS1, which is matter and its interactions, and you can see the title up here at the top of the page. PS1, matter and its interactions. Okay, the second thing that I'd like for you to notice, because it talks about the 3 dimensions of learning here. And so if you look at and the reason why we wanted to give you this in color, because it's very obvious when you look at it in color, you see 3 different colors down here at the bottom. The title of the one in blue is what?
Science and engineering.
Science and engineering practice. What's in orange?
Disciplinary varieties.
And what if you were talking to someone about this and you didn't want to use the academic language of disciplinary core ideas, what would you call this orange part?
Troubleshooting, misconceptions.
Main idea.
I call it science content. Isn't that science content in the middle there?
The meat and potatoes,
Pardon?
meat and potatoes of it, just the basic.
Okay, and then what is green? Look at green. It says cross-cutting concepts. So to me, I'm gonna go back to what Quentin said, I call that the big ideas. So the big ideas of patterns in nature, the big ideas of cause and effect, etc. So when they were writing these new standards, these were the 3 things that they said we need to have in our standards. And we need to make connections among them. And so that's how they came up with the next generation science standards, but they based it on the framework for K-12 science education. So you have to use both. If you're trying to understand the content and the cognitive level, you have to do the readings in both. In the framework, there's only about 2 pages on particulate matter of nature, so we're not talking, about a lot of reading that you would do. But you still need to look at both. And then also, if you turn back on, I'll just use a middle school, look at the back of the page at middle school. So what you see down there in white, there are some other notations there. So it says Common Core State Standards Connections. We don't use Common Core because it's illegal to use ELA and Math Common Core in Texas. But these are the same concepts. So they're keyed to Common Core. But if you look at the narrative that describes them, you'll see they're the same, critiques that we have in ELA and Math. And so the idea that you can still use this to make those connections, even though we don't use Common Core. And again, I would go to your ELA and obviously your math teachers, to where this, that you might share with them, these are the kind of connections that we are making in science right now, and then have some kind of conversation so that they might, at least, as we said, for you guys, mention it. In science, you're learning about inferences of patterns in nature, and you give the ELA teacher, a leaf with galls or whatever it is, so that students would make that connection back to the science classroom. So you may be sharing some materials with them, but this is important to have the ELA teacher have this to be able to make that connection back, for example, with inferences. So, yes, question?
So using this, because one of the big things, especially I guess on the elementary campus, is we have to have the big idea, what's the learning target, driving question,
Mhm.
is this something we could use as just a foundation,
Absolutely. Absolutely.
something displayed that,
Well, I mean, you wanna do that, you know, that deep thinking about it and taking the ideas, you might not take it word for word, you might just take part of it.
right,
Uh,
but I mean, so having the driving question that the students have to begin with, and then get into the concrete, so we wanna answer this question at the end.
Yes, yes,
Okay.
yes, you could. But if the question is too big for them to think about, then you may need to divide it up into sub-questions and then
Right.
to the end.
Okay.
Yeah, so thinking carefully about it, not just automatically say, okay, this is what our standards say, so I'm gonna put it up on the board. No. You know, as professionals, we have to think our way through these recommendations and see how they fit. But I think if you'll start using them, I think you'll find that you'll be thinking a lot more deeply about your TEKS, and a lot better, instruction will result from that. Okay, so just again, the idea of the framework and the NGSS, we also have the NGSS books here for those of you who do not have them. Books. Okay, and math, we have them for everybody, it's not just for science. If the math teachers want them, we also have them for you, so.
Also,
Yeah,
Master
plenty.
Connect has an app, Master Connect app, Android and Apple, that has you can have the TEKS and the NGSS, and you just put in grade level, and it has a search. If you have like one word, it'll search for you, and you can go by grade level and the strands, you can search by.
Is that easier than doing a word search on the original document?
The paper document is still good, because you can flip it.
No, I'm
Oh.
saying, you have a PDF, you can download a PDF, so is
It's
that,
much
Yeah,
easier,
it's easy.
much
it's
easier.
easier than just looking, doing a
And
word
it's
search?
free.
That's even better, right, so. Okay, so, I want you to see some differences. So they have combined scientific and engineering practices in our new standards. And I think it's important to see the difference between science and engineering. That has always been an issue. And so are we in science expected to also teach engineering practices, i.e. STEM, whatever? But it's not science, it's engineering, it's different. It's a different science. So what they have said, I think that helps me understand it better, is that in science, scientists ask questions, they're research questions, whereas engineers are defining problems. They both develop and use models, they both plan and carry out investigations, they both analyze and interpret data, they both use mathematics and computational thinking, but in science, we construct explanations to answer the questions, and in engineering, we design solutions to solve the problem. And I think that is not clearly differentiated for us in our fields. It's just kind of all thrown out there in this amorphous mess, and we don't know which is which and how to do either one of them. And I think, requiring science teachers to also do engineering problems or build models and so on like that is solving a problem. Not a model, like this, it's part of science, it's different. I think needs to be a big discussion in the district, because you're required to teach the TEKS, you're not required to teach engineering. Do you have time to do that? And teach the fundamentals, because if they don't understand the science, they can't use it in the engineering. We'll talk with Lori about that later, because that's what she's doing with her math classes. They both engage in argument for evidence. This is a big issue now. It's, ADI, et cetera. I have a problem with ADI because there's some incorrect components of it that has to do with investigations that I think you should be alert for. But, being able to argue, being able to argue evidence, argue with evidence is important in everyday life. It's important, Wendell and I have these conversations all the time. And when we first got married, he would get really disconcerted when I would say, essentially, what is the evidence for your answer? And he, it'd usually be from the internet or something like that. And so, when when we started having a lot of those kind of conversations about, you have to have evidence, and the evidence has to be, one that you have confidence in. Dr. Browning?
I'm not real sure I know what ADI is.
Argument,
Cause I keep
driven
seeing
inquiry.
Argument-driven inquiry.
Uh-huh,
Inquiry.
yeah, it's out of a UT, guy developed that, it's
Okay,
taken a long time.
thank you.
Okay, who else was not familiar with ADI, argument-driven inquiry? There's lots of sessions on that at CAS, there's training that you can take at UT with it, and Laura's done it, and she's incorporated a lot of that into her instruction. So it is good because what it's doing, it's requiring students to provide evidence for their inference, if you would, for their answers. And that they've got to go back to their data and be able to say, therefore, the data say yada yada, and then what kind of inference perhaps that you might make from it. So it does certainly have some good thinking in there, and that we don't see this in classrooms. We don't see teachers requiring students to provide evidence for their answers, so to speak. In my classroom, that's kind of a joke because that's what we're teaching our pre-service teachers to say, what is the evidence for your answer? In a lot of ways, it may be, can you explain your answer, Ashley? Elizabeth, can you restate Ashley's evidence, and do you have any more evidence, either contrary or anyone disagree? What is your evidence for disagreeing with Ashley's statement or whatever? So those kind of conversations in classrooms are really important if we want kids to think. Yes.
I was gonna ask, what's the difference, or a big difference between ADI and like claim evidence reasoning?
I think it's nuances of the same thing.
Okay.
Claim evidence and reasoning it's using the same skill sets. And then, of course, obtaining, evaluating, and communicating information, which is what scientists do. Okay, let's take a quick break. And you can put these pieces of paper from the NGSS back into your plastic slip. We have those are yours to take us. Okay.